What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at conditional probability in cards. So conditional probability is where the outcomes possible change because of what you already know. And this is super applicable to cards because you obviously know what you have. And in a lot of card games, cards get played by all players into the middle, which you can see. So if you can kind of remember what cards have been played, you know that the sample space will change, which completely changes the probability of you winning or losing as the game progresses. So if you're not 100% sure on the probability of cards in general, I do have another video on the probability of cards just as kind of an overview. So I would recommend having a check of that. But instead, we're just going to jump straight into scenarios where you know what you've got in your hand, and we're trying to find out what is the probability of a certain outcome occurring after accounting for what you know you have. And just a reminder, we've got specific language for these. We have the probability of A given B, so the probability of finding something, an event, given what we already know. The formula for this is A intersection B divided by B. Again, if you're not sure where that comes from, please have a look at the last lesson on conditional probability. So for this scenario here, if you pull an 8 or a 9 out of the deck randomly, you will 100% lose. And these are the cards that you know you've got. So what is the probability that you're going to lose? So what we've got to do to get this right is we need to identify the A and the B. So identifying A is the 8 or 9. This is what we want to avoid. So we know there are 4 8s and 4 9s. So we just multiplied that by 2. There are 8 of these cards in total. But I can already see that I have 2 of these in my hand. That's information I already know. So there are only 6 possible ways that I could lose when I pull that next card. And then to find B, the new sample space, right, given what I've got, it means that there's not 52 possible outcomes. I actually have to minus the 7 that are in my hand. And this is just equal to 45. So the probability of me pulling an 8 or a 9 randomly as the next card isn't 8 over 52, it's 6 over 45, which simplifies down to 2 over 15. And that's all these questions are. Looking at what you've got, knowing what is possible based on your hand, and then just applying these simple probability calculations in order to know. So this scenario is a little bit more likely. In a game, you would have cards played in the middle plus what's in your hand, and you've got to use both of these pieces of information to work out the probability of winning. So in this one, we've had 14 cards already played. You've seen them. If you can't remember them, that makes this a little bit tougher, but we are assuming that we know what is in the middle. There are 14 known cards. And then you also have these 6 cards in your hand. So that means we know there have been 20 cards in total accounted for. So the remaining cards are 32. There's the sample space of the possible outcomes remaining is only 32 cards. And we want to know what the probability of pulling a royal is. I've said that 2 have been played. You've seen them go out into the middle. And we've got 2 in our hand here. So we need to find the probability of a royal is pulled next, given what's been played and what's in our hand. So there are 12 royal cards usually, and we have to minus the 2 that have been played, minus the 2 in our hands, leaving us with 8 remaining royal cards. And then just to work out what the sample space is, or the B, we have our 52 cards minus the 14 played, minus the 6 in hand, so there's only 32 remaining. Again, this is pretty easy. All we have to do to work out the probability is that the 8 cards we have, the royals that will get us the win, divided by the 32 remaining. 8 over 32 simplifies down to a quarter. Happy days, we are done. So this is a really easy application of conditional probability. We didn't have to use the formula. We weren't looking for the intersection of things. We are just changing the sample space based on the things that we know. It's quite intuitive. And I do think it's a really easy way to get a grasp on these probability questions. I would highly recommend for homework playing a couple of card games with your parents, with your brothers and sisters, or with just some mates, because I guarantee it will help you just kind of understand these probability questions more intuitively, especially if you are competitive and you definitely want to win. Thanks so much for watching, guys, and I'll see you later.